Today we're going to talk about section 5.1, positive integer exponents. So we have now completed our study of lines and systems of linear equations. We're switching gears to begin with a review of exponential notation. So exponents represent, what do exponents represent? Repeated multiplication. Definition: for any real number a and natural number n, a to the n is going to be a times a times a times a, however many n factors. So for example, if I have 3 to the third power, a lot of people tell me that 3 to the third power is 9. It is not 9. It's not 3 times 3. It's going to be 3 times 3 times 3, because that 3 tells me to repeat the base that number of times. You're right, it equals 27. It's a perfect cube. Write the following using exponential notation. So our base is x. 1, 2, 3, 4, 5, 6, 7 is going to be our exponent, x to the 7th, right? Here, 3b, 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 this is going to be 3b to the what? To the 4th. Now another way of writing that, you notice that I have 3 times itself. That would be 3 to the 4th times b to the 4th. This is not the same as 3b to the 4th. You see why that's different? Because that 3 without the parentheses would not be taken to the 4th. When I take 3 to the 4th, does anybody know what 3 to the 4th is going to be? It is 81. 81b to the 4th would be another way of saying that. Because 9, if you think about 9 squared is 81, well, 3 squared would be 3 to the 4th. That's 81, right? Write the following using multiplication notation. So basically, this is what we call expanded notation. So this is saying x times itself 3 times. Notice this is not the same thing as 3x, right? Don't get it confused. That 3x would be just 3 times x, as opposed to x times itself 3 times. Okay, if I wanted to use expanded notation here, I would have 5y times itself. How many times? Yes, 5y, 5y. Okay? And then here, if I expand this, I have x times itself 5 times, and then times 2 more. So this is x to the 5th. This is x squared. Is there a way to simplify if I have x to the 5th times x to the 2nd? Notice that the bases are the same. Is there a way to simplify that? If I were going to write it, it would be what? X to the 7th. X to the 7th would be the simplification of that, and that's actually going to be our very first rule, the product rule, but we're going to talk about that in just a second. Okay, if we expand this, we have y to the 8th. Y times y. How many times am I multiplying y by itself? 2, 3, 4, 5, 6, 7, 8. Now, if I multiply y to the 5th, 1, 2, 3, 4, 5. Do you think there would be a way to simplify this? Oh, because what is y divided by itself? 1, 1, 1, 1, 1. What's left? What do you do with 8 and 5 to give you 3? Subtract. That's the second rule. We're going to talk about these two rules. So we just discovered, note that example C and D could be simplified. Okay, we just did that. Use the pattern you see to try to come up with the product rule. Why is this one called the product rule? Any ideas? Multiplication is product, and then we're multiplying, right? The product rule and the quotient rule. Why is this one called the quotient rule? Division, okay. So the product rule, when multiplying two exponential terms with the same base, we can what? What did we do to the exponents? Add the exponents. So in general, notice that the bases are the same. A to the m times a to the n is a to the m plus n. Those are in the exponent. For example, x squared times x to the third, that would be x squared is x times itself, x to the third, 1, 2, 3, and that would simplify to x to the fifth. So what I suggest you do, there's going to be a lot more rules coming up. Okay, this is not the only rules we have for exponents. Give yourself a simple example like this. If you ever forget the rule, prove the rule. Okay, when you expand it, you prove the rule, don't you? You can see it, it becomes obvious. The quotient rule, the word quotient means answer to division, right? The quotient rule, when dividing two exponential terms with the same base, we can, what did we do here to the exponents? Yes, subtract the exponents. So in general, a to the m divided by a to the n is going to be a to the m minus n. Those are your exponents. So x to the fourth, 1, 2, 3, 4, that's expanded, divided by x squared, x times x. We notice the reason why we're able to come up with that rule is because we canceled, right? X divided by x is 1. So what did this simplify down to? X to the second. So again, if you forget the rule, be sure to prove the rule, okay, by expanding. Any questions so far on that? Those are our two most basic rules, the product and the quotient rule. Okay, try applying these rules along with the associative and commutative properties to simplify the following expressions. So here we're multiplying 3x to the fourth, 5x squared. Now does the 3 have an exponent that we have to deal with? Does the 3 have an exponent? What's its exponent? No, because the 4 is on the inside of parentheses. Ah, you see that? So we're really just multiplying 3 times 5 times x to the fourth times x squared. So what would that simplify to? 15x to the sixth. So the difference is that exponent of 4 is not outside the parentheses, so therefore it's not affecting the 3. The 3 is actually to, if you want to know its exponent, it's to the first power. But that could be, don't overthink that too much. The first power is just itself, right? Okay, what do you think about b? What would you get if you multiplied these together? Who can tell me? X to the 6th, y to the 7th. Does everybody see where he got negative 15, x to the 6th, y to the 7th? Any questions on that? All right, let's go on to our division problem now. 27 into 81. Any ideas? 3w squared. 81 is the same thing as 3 to the fourth. 27 is the same thing as 3 to the third. That's why you get 3 left over, right? Well, we were just talking about 81 and 27 on the previous page. But if you just divide 27 into 81, it will go 3 times. Does everybody see where we got the exponent of 2 from? Yep, you subtracted exactly right. Okay, what about D? Who can raise their hand and tell me the answer to D? Yes, go ahead, Aaron. Y. Questions on how we got that? 7 divided into 42? Uh-huh. Yes. Remember that's a y first. 2 minus 1 is 1, right? Okay, let's develop some more exponent rules. Write this using multiplication notation. That means basically expand it, right? So I'm going to write xy times xy times xy times xy. And how many total? 5. Now let's use the commutative property to group the x's and the y's using exponent notation. So how many times am I multiplying x here? Yes. How many times am I multiplying y by itself? 5 times. So we have x to the fifth, y to the fifth. Essentially what that means is that that exponent of 5 is going to go to both of those variables. Okay? If we expand this now, if I say x to the third times itself, what's that give me? X to the third squared means x to the third times itself. And that's going to give me x to the 6. So what do you think the rule is using 2 and 3 when we have, this is power to a power? What did we do here with 2 and 3? We added them when we wrote it as multiplication, but when we have power to a power, we have x to the 6. Now rewrite it using exponential notation. We did that right there. Use the patterns we just developed to have a few more of these properties. So the product to a power, when raising a product to a power, we can, what should we do? Basically give, yeah, distribute the power. I like that. Distribute the power. I was going to say give the power, but distribute, that makes more sense, right? Okay, so for example here, we would have a to the n, b to the n. What would this one be? X to the y to the third. Good. Power to a power. When raising an exponential expression to a power, what do we do with the exponents? Multiply. Multiply the exponents. So we're going to have a to the m times n. For example, if we have x to the fourth to the third, that's x to the fourth times itself 3 times. There's my expanded. So what am I going to have? X to the 12th. Good. Quotient to a power. When raising the quotient to a power, we will also distribute the power. So here we'll have a to the n over b to the n. And this is, oops, n. That's because of the parentheses, okay? So what will you have for this one? 2 to the third, yes, 2 to the third over 3 to the third. Now, because those numbers are small enough, you know, if it was 2 to the 100th, okay, fine, don't write the number. That's going to be way too big. But if it's 2 to the third, can you give me what number that actually is? 8, good. 3 to the third is 27. So, and can 8 over 27 reduce? No. That's because you only multiplied 2 and you only multiplied 3. They have no common factors, okay? So we'll go ahead and come on to the last page here, some trickier type problems. So go ahead and try those, and then we're going to go over them right now. So does anyone want to tell me what the answer is to the first one, 5A? Yes, 27x cubed. Good. What about B? This is a little harder, huh? So you could take it step by step. Negative 2 to the fourth. X squared to the fourth. So what's negative 2 to the fourth? Is that going to be a positive or a negative? Notice the negative is in parentheses. Positive what? It's going to be 16. And then what about this one? It's going to be x to the 8th power. Good. X to the 8th power. Good. All right, what about this one? 2 squared over 3 squared is 4 over 9. Excellent. Okay, there's a lot going on here. What should we do first? Can we just go ahead and multiply them, or do we need to do something first? Yes, because remember, order of operations is before we multiply these, we need to do exponents first. So here we have 3ab to the 4th. That stays unchanged. So what's that going to be? 2 to the 3rd. 2 to the 3rd is what? A is going to be 8, right? 2 to the 3rd is 8. What's this one going to be? A squared to the 3rd. Okay, and b to the, good. Now we're going to multiply these two things together. What do we get when we multiply those together? 24, a to the 7, b to the 7. Because that's the product rule now. Yes, because that's the product rule. We're multiplying, so we're going to use the product rule. Okay, what about this one here? Yep, so everything is taken to the 3rd power. What's x squared to the 3rd power? Good. What's y to the 4th to the 3rd power? Good. Over, everything gets taken to the 3rd power. What's 2 to the 3rd power? I said the answer. 8. And then x cubed, z cubed. Is that done? Is that fully simplified? No. What could be simplified about it? The x's. Only the x. That's the only thing that's the same, base, right? So tell me what to write. Yep. Right. Z cubed. So you see what happened? There's no more x in the denominator because these canceled, right? X to the 6th divided by x to the 3rd is x to the 3rd. So that's where that number comes from, okay? Now let's look at the next one here. What do I need? This is like so much going on, but don't get overwhelmed. Just take it one step at a time. What's the very first thing that we need to do? Okay, distribute. So we have 3 squared is 9. Squared. Squared. Yeah. 2x squared. Okay? Oh, wait. My denominator. 4x to the 4th. Where am I getting that 4th? Yes. Okay. Now, what we can do, let's simplify this. Can we simplify just this part and then we'll simplify this other part? So we have 9 over 4 cannot be simplified. What about the x's? X to the 4th, y squared. Good. Now let's simplify this one. There's no exponent other than 1, right? So we don't change anything. We have a 4 because there's nothing to cancel. 4 over 1. What's the x going to be? Squared. And then y cubed. Okay, now I'm going to bring that down. 4 over 1, right? If we want, because we have nothing else in the denominator. Okay, tell me what do I have now? What can I simplify? What's 36 divided by 4? Because you look at that. That's a cross cancel, right? So 9, oops, that's a 9, not a Q. 9, x to the 6, y to the 5th. Okay, any questions on that? That one's a lot trickier. Now what I'm going to recommend you guys do is flashcards. So you want to get these rules so that they're like your times tables. You can just do them from your mind. Was there a question about this? I saw. Okay. So does anybody know the answer to this one? 101. Yes, X to the 101. So what I suggest, you can make flashcards. You can even put the answers right on the back, X to the 101, and you could have your friends and neighbors and children and loved ones quiz you on them if you want. Okay? So here's just the idea of how we could do it expanded. Okay, let's just do these for mental math. X to the what? 99th. You guys, you can't do this one because there's addition, not multiplication, and these are not like terms. Oh, we're going to get into that next. So that one you cannot there's no multiply. So you have to remember that this is product, right? Can't do this one either, so that's good. You want to keep yourself sharp. Okay, what about, oh, we haven't talked about the zero exponent. Yeah, because if you add 100 and 0, you get, we're going to talk about zero exponents later, but 100 plus 0 is just 100. Okay, let's do this one. 9x to the 6. Because 3 plus 3 is 6, right? We're multiplying here. Okay, what about this one? Negative x to the 11th. Good. What about this one? Oh, no, no, no. Add. You see the difference? You can't add these because they're not the same exponent, so we can only multiply them. That's why I keep throwing it in. What about this one? Have you seen problems like this before? What's x squared plus x squared? No, 2x squared because of the plus, right? So we're going to other rules, adding like terms, combining like terms. What about this one? Good. X to the 12th. This one? Good. X squared y to the 6th. Negative 63 x to the 9th. Good. See how you can really step it up here, huh? 6, okay. 81 x to the 6, y to the 8th. Good. Okay, here you go. 16 x squared, y to the 6, z to the 4th. It's supposed to be 4th. Well, that's a 2. That's why I put the cross through the z so it doesn't get confused with the 2. What about this one? No. X to the 30th. Okay. There's a lot of 3's in this problem. Negative 27 x to the 9th. Okay, so you guys get the idea. Like, we could go and do this all day. And then we could also, we could make some division ones. Yeah, they are. They can, and you can make them harder. So if you want to borrow them, you can. You can make them up. You can get problems from Connect Math. Oh,